class! We're going to start with the second part of graphing rational functions. We've already looked at holes and vertical asymptotes and defining the domain. This time we're going to look at the horizontal and slant asymptotes. So if we're given the rational function f of x, and it equals this fraction where the numerator and the denominator have polynomials, we're going to use, for generalization, that n is the degree of the numerator and m is the degree of the denominator. And when we compare those, we're going to look at what the n and the m, and that will determine whether or not we're going to have a horizontal asymptote and how to find what that is. So if n is less than m, then the horizontal asymptote, and I'm just going to abbreviate that HA, is going to be always y is equal to 0. Now, if they're the same thing, that n equals m, then the horizontal asymptote is going to equal y equals a over b. So these will be the coefficients of the leading term in both the numerator and the denominator. And then our last one, if n is less than m, then there is no horizontal asymptote. But if n is less than m by 1, so n is equal to h plus 1, or I'm sorry, if n is equal to m plus 1, then we have a slant asymptote. And sometimes you'll see the word, O-B-L-I-Q-U-E, oblique, not A, it's O. Oblique. I just used the word slant. Then we're going to use long division. And the slant asymptote is going to equal, it is y equals the quotient not including the remainder of that long division. So let's take a look at some examples finding the horizontal or the slant. If you have one, you cannot have the other one. It's or. You cannot have both. Or. So on this one, we've got 9x squared over 3x squared plus 1. So we're going to say n is the degree of the numerator, which is 2, and m is the degree of the denominator, which is 2. So our horizontal asymptote is, since they're the same, we're going to have y is equal to a over b. And so a is 9 and b is 3. So our horizontal asymptote is y equals 9 over 3, or y equals 3. So that's our horizontal asymptote for this particular function. On example B, we're going to find the horizontal and slant asymptotes for g of x, and our n, which is the degree of the numerator, is 1. So if we don't have a number there, it's considered to be 1. And the degree of the denominator is 2. So n is less than m, and when it's less than m, the horizontal asymptote is always y equals 0. Our third example is h of x. We've got 9x cubed divided by, or over 3x squared plus 1. So our n is equal to 3 and m is equal to 2. So n is greater than m and n is equal to m plus 1, right? 3 is the same as 2 plus 1. So because of that, we are going to have a slant asymptote. So we're going to do some long division. This is my dividend, 9x cubed. So I'm going to have 9x cubed plus 0x squared plus 0x plus 0. That's going to be my dividend. My divisor is going to be 3x squared plus 0x plus 1. Now remember, in long division, we're going to say, what does 9x cubed divided by 3x squared, what does that equal? Well, that equals 3x. So then I take that 3x and I multiply it by all the terms. So I get 3x times 3x squared is 9x cubed. 3x times 0x is 0x squared. And 3x times 1 is 3x. And then I'm going to subtract all of that. 9x cubed minus 9x cubed is 0. 0x squared minus 0x squared is 0. 0x minus 3x is negative 3x. We're going to drop down the 0. And this is our remainder because 3x squared doesn't go into negative 3x. So what this part of the quotient without the remainder is going to be our slant asymptote, and we write that as y equals 3x, because this is our slant asymptote. It's a line, that's why it needs to be an equation. And our last example, j of x, has 9x to the fourth over 3x squared plus 1. So we're going to say that the degree of the numerator is 4 and the degree of the denominator is 2. So n is greater than m, and n does not equal m plus 1. So we have no horizontal asymptote and no slant asymptote.